Hello, Nano fam! It's been a long time, and this time we have a very special stream because we have the amazing Colin LeMahieu with us. And yeah, Colin, I don't think you need any introduction because everyone in the space knows you very well. So, Colin LeMahieu, the inventor, the mastermind behind Nano, and I'm so honored that you took your Tuesday evening off to look at my messy code base instead of doing what you would usually do. I don't know, maybe enjoying a Netflix movie or I don't know. So we
Yeah,
will have a nerd evening today, and I'm very grateful that you took time for that. So welcome, Colin.
yeah, thank you. No, it's great to be here. And yeah, I think we've been talking about this for a little while, and glad to finally put it together.
Yeah,
Yeah, this is going to be great. Can't wait to see do a deep dive into everything that you've been working on for so long, and on the Rust part of this. Very interesting. I've been learning Rust a little bit myself, um, with thanks to very helpful AI tools, which are extremely cool. But yeah, I get to see some stuff in production, so very excited.
yeah, I'm excited too, and I'm especially curious about what you have to say about the things that I made differently, that I changed from the original code base. So yeah, I don't know what we are
Cool.
going to do today exactly, but I think it will be interesting.
Yeah, yeah, let's do it.
Yeah, let's welcome chat. So let's maybe switch to the chat view. Can you see the chat? Oh, so many messages already. Okay, I'm not able to read all of them. So just welcome to all of you, and chat if you want, if you have questions, if you want to say something, just yeah, write it in chat. We can read it here. So our plan for today was to go through a couple of um, parts in the Rust code base where I made where I changed things. And yeah, Colin, you said like maybe we could talk about is it better, is it worse? It can is would it make sense to make the same kind of changes in the C++ code base too? Yeah.
Yeah, yeah, absolutely. So I know that you made a couple of really good improvements, stuff that, we have always wanted to do. Um, but then I think there's a couple, well, I think that, and then there's also a couple of things that you pretty much had to change, because I think Rust is enforcing probably better modularity, amongst everything, and which would be very interesting. And then, yeah, I guess some like performance things that you've improved on the networking. And yeah, I think you had a
Yeah.
nice little list of stuff that we could take a look at.
Yeah, I put together a very rough list. So this is also the list that I shared with you. Some ideas of stuff that we could have a look at today. Um,
Yeah.
yeah, and as you said, like Rust forced me to make some changes. Just because Rust expects the code to be in a DAG structure. So just
Yeah.
like the blockchain. So the Rust works really well if the code is organized in a DAG structure. And
Yeah, that's some stuff that like C++ has inherited, well, from C. And that's like the linker versus the actual compiler stuff. Like you can do things really messy, um, and it especially gets bad when you start moving things around and you don't realize the cycles that you left in there, and the compiler doesn't tell you because yeah, the linker fixes it up, but really, you have a design issue. So
yeah,
I think, from what I can tell, Rust enforces that, which is, yeah, probably good. I think all the modern languages are doing that, like C sharp would, and anything new.
yeah. And I had a quick thought in the beginning if I would just keep the dependencies as they are, but that would force me to use shared pointers or the Rust equivalent args everywhere. And with the shared
Yeah.
pointers, you just disable the borrow checker, and the borrow checker is this huge helpful uh, tool that Rust gives you, and to not use that would be such a shame. And that's why I decided to remove all dependencies and almost almost all dependencies. And that was a lot of work and caused a lot of pain. Yeah. I mean, we could.
Yeah. Does it actually disable the borrow checker, or does it just allow, like, I guess, multi-threaded race conditions? Because it wouldn't allow the memory to, you know, be invalid, right? It would just, but it could allow like a race
Yeah.
condition.
And it would allow memory leaks. And
Oh,
yeah,
sure, yeah.
so the nice thing with the borrow checker is that you have very well-known points where objects get destroyed, and you know the lifetimes exactly, and you can reason about them, or the compiler can reason about them. And by using args, you throw all of that out of the box, and you can just create your memory leaks. And I created a lot of memory leaks in the beginning when I ported it, because I had to start somewhere. So I started with args, with the goal to gradually remove them. And during that time, when there were so many args, I had a lot of memory leak issues.
Yeah. And I guess those would be live leaks. Is that like cycles that were left over
Yeah,
and they
yeah,
never went out of
exactly,
scope? Yeah.
exactly, cycles. And there are still a lot of args in there. So let's just jump right into the code base, into node.rs. So
Sorry, what is it? What is the editor that you're using, by the way? I've seen you use this, but
this is NeoVim. So I'm, yeah,
okay.
yeah. Okay, so this is not a, this is just for people who like that old school style. And I was a Vim user way back then, and I fell in love with it, and it's yeah.
Oh yeah, cool. Oh, right down at the bottom it says that. Cool. Yeah.
Yeah, so what we see here when we start in the node rs file is that all of the initialization that happens in the constructor in the C++ code is happening here with in sequences. So there is no node reference, the thing that I always keep complaining about, the circular references with node.
Yeah.
All of that is gone. So we have all of these components like online reps, like telemetry, bootstrap server, and there's a clear how to say one thing after the other, and the dependencies are explicit here. So I know the bootstrap server is dependent on the stats and on the ledger and on the message publisher, and the rep tiers is dependent on this thing, and all dependencies are explicit, and the borrow checker makes it impossible in this style to have circular dependencies.
Yeah, that's interesting. So you had, yeah, I mean, I can see the circular dependencies being an issue there. I mean, like, obviously the benefit of this is that you, know the exact dependencies. You don't have memory issues. I mean, I mean, basically the strategy that we have on it, or at least the one that I do, is sticking, if I have to add something to the node class and use that node reference, you kind of have to find out where the initialization order doesn't crash.
Yeah.
And
And I had those crashes too. Yeah.
Yeah,
Yeah.
exactly. Okay.
Yeah. But as you can
But
see,
then, yeah, the minus is that, yeah, you have to do these big initialization things to pass each pointer.
yeah, and this is still ugly. So, and as you can see, there's still clone. So all of these are still arcs. So on my battle against arcs, I'm far from finished. Yeah, so we have to wait.
How are you doing that without arcs, like on some of these, like recently confirmed?
Oh yeah, so I have a plan. Let's see if I have the spike code in here somewhere still. I have a plan, and the plan was to use references. Where did I put that code? I think I have it in temp. Yeah, run node spike. I think it's this. Yeah, so my plan is to not have a node class. but instead to just have a run node function. And then it will create all of these components as local variables. And then you can just pass in references. And at the end of the function, so the function will run as long as the node will run. And when the function returns, all local variables will be dropped. And I just have to make sure that, that the function keeps running while the node runs. And then I can get rid of all of the args or most of the args.
Okay, interesting.
So,
All
so
right,
this
so this
is
is like a prototype that you're playing with?
yeah, that was a prototype. I was really annoyed by all of the args that are still in there, and then I thought, what would be a way to not have args in there? And this was a prototype, and it also includes async code here, and yeah, I just wanted to see if this is a doable solution. And yes, so, and this compiles and it runs, and this is something that I have planned for the future.
Okay, interesting.
Yeah, it has some downsides.
Cool.
So this will not work with the way the tests are written now, for example, because the tests, they require a node class.
Yeah, I know we talked about the tests a little bit before, and I know, I call them unit tests, but by some measure they're like integration tests. What I guess the method behind the madness on that is basically, I think, like, if anything you can't make multiple of them. Yeah, basically like nodes, spinning multiple nodes up very easily. It kind of indicates an issue with your like componentization, I guess. So yeah, I guess as long as something like this, you'd be able to run multiple nodes, that would be fine. Because I mean, I guess most people would never run more than one node in a single process, but who knows?
Yeah, so the multiple nodes in a single process, I would want to go away from that. So the tests that the C++ tests as they are now, I think they have value, and I think it makes sense to have at least a couple of tests written in that style. And I think you said yourself that those tests are giving more confidence that things work, and that when you make the tests too granular, that you could have passing tests, but the real production system would maybe have bugs in it.
Yeah, it's a little bit of like give and take on it, because some of our tests, like, you have to spin up an entire node to test a single component in there, and that's not good. We should be, but that just indicates that whatever component we're testing is too tightly coupled with the node, and it should be decoupled in some way to not require a node. So yeah, I guess the part where it would be helpful is to see how like multiple nodes interact with each other over the network. But
and that's also the test that Bob writes. So I think those tests are good. I just want to change the amount of tests. So I want to have a lot more very specific fine-grained unit tests.
yeah,
and then I want to have those tests with multiple nodes, but they I would like to run the real executable. So just like Bob does it in his tests. So what do you think of that?
Yeah, I don't see a problem with doing it that way. I think that works, and there's reasons to do it that way. It's kind of the same reason I always try to avoid ever using a singleton. I have a pet peeve in that the first like pattern they teach people going through classes is a singleton, and I think that's probably the worst pattern out there, because it works until you want two of them, and then all of a sudden I have to redesign like the entire class structure, and I don't think there's barely a reason to do it. It's the same thing with globals, like why you don't want to use globals, why you don't want to use singletons. You just don't want to build yourself into a corner on that. but when your application's big, the reason to run multiple of them in a process, it does tend to go away. So
Yeah, fully agree.
yeah.
I fully agree. I'm also very strongly against singletons for the very
Yeah,
same
I
reason.
know.
Yeah. And of
Yeah,
also
I remember that in like a CS class, they like in Java, they were teaching singletons and like going to extraordinary lengths to like prevent serializing the object and deserializing it in order to prevent like multiples. Like, why are you going through so much effort? If somebody is actively working against, your design, you just,
yeah.
yeah, you have bigger problems.
And the funny thing, just like I said, if you ask the people like, okay, so are global variables a good thing? And they say no. And you say, is a singleton a good thing? And they say yes. And then you say, what's the
Yeah.
difference? It's the same
Yeah, they are
thing.
the exact same thing. Yeah.
Yeah, and if not,
Yeah.
is Bob the AI assistant? No, Bob is Gravity, in case you didn't know. All
Yep.
right.
Bob has been writing these very helpful analysis tools. Yeah.
Yeah, and he also helps me a lot. So with the bootstrapping tests that I did, he was he was like constantly there with, oh, Gustav, have a look at this. Gustav, have a look at that. This block is not confirming, and really helpful. So he saved me a lot of time.
Yep.
Yeah. Anders Blau says, maybe a question for later. Colin, first of all, it's cool to see you here. Question: how did you perceive the whole situation with BitGrail? Did Nano as a community recover from it? I don't think it's relevant today, but do we answer questions?
Well, we can. That one's just an annoying question.
Okay.
This is like, there's nothing I can do about some weird guy in Italy
Yeah.
blowing up as an exchange. So, yeah.
Yeah.
Let's do some code.
Let's do some code. Okay, so where should we start? What interests you in particular?
Let's see. The heap allocations, I think, would be really interesting because, yeah.
Let's start there. So the heap allocations when sending and receiving messages. So please help me out with my knowledge of the C++ code base is getting rusty.
Well,
It's getting rusty.
yeah.
Yeah, so if I remember correctly, in the C++ code, when messages are sent, a byte buffer, a shared pointer to a byte vector is heap allocated. And I think for every message, right? So maybe.
Yeah, so this, you're asking about the C++, how we do it right now.
Yeah.
Yeah, so I think we have a single buffer that it's a single byte buffer that we deserialize to, but then we heap allocate objects and copy the data out of that buffer into the object. And then we reuse that byte buffer
for the receiving side. Yeah. So I'm not sure. I don't have the C++ code in my mind anymore. I vaguely remember that there were some places where when we sent messages that required heap allocations for the byte buffers, because the channel send function would take.
Oh yeah.
So this is not completely heap allocation free in Rust yet, but I tried to minimize the heap allocations, and I tried to reuse the buffers for sending and receiving. Yeah, let's just have a look at the code. So maybe let's start with the messages, because I changed the messages a lot, actually. So I tried to separate the serialization logic from the messages themselves, because in the C++ code, the header, for example, the message header is tightly coupled to the message itself. And my thinking was the header is an implementation detail of the transport layer. And just the fact that we send a message header should not concern us when we create messages. And that's why I went with the very basic enum type of Rust for messages, where a message would be just the data that we want to send. For example, which message would be a good example? I don't know. The publish. Yeah, so the block publish would just contain the block and these fields. And there's no concept of a header in here. And I extracted the header into a trait. And the trait is called message variant. And there a message can just return the extensions. And the whole serialization and deserialization, which is in the message class in C++ itself, I think, I just extracted that into, let's see, where do I have to look for that? I extracted that into the message serializer and deserializer. So that is a struct here that uses one buffer. So this is now the place where a heap allocation is made once. So once per component that sends messages. So I create the message serializer, I think. So if there are a couple of threads and each of those threads send messages, I create a message serializer for each of those threads once, so that I don't have to lock the buffer. And then there's the whole code for serializing the header. And then, so here's the header. And then serializing the message itself is, like I said, separate from the message. And that simplifies the code a little bit, because whenever we want to send a message, we don't have to need to know about those implementation details.
Okay, so let's see. We got serialize, which takes the message, and so it won't know the specific implementation of it, and it returns a UA array of bytes.
Yeah,
so
and as you can see, it returns a reference. So this is just a pointer to the internal buffer. And whenever we call serialize, we reuse the buffer.
Oh, I see. Okay, so that's what you were talking about before. So message serializer is one per thread, so you don't need to lock it.
Yeah, exactly. So let's see who calls that. Who calls the serialize? Yeah, message serializer. No, sorry, we are here. No, message publisher. Yeah, so message publisher. I don't know. This doesn't exist in C++, does it? I think.
What's that?
This is a struct that I use to publish messages to other nodes. So I have a function. Oh yeah. Oh, this is interesting, Colin. I'm curious what you have to say about this. So we have a try send function, which takes a reference to a message. And channel, I don't even know where to start. There's so many things different here. So channel ID is probably is new for you, I guess. So in the C++ node, channels are identified by their memory location in many places. So in the containers and stuff, it's the shared pointer. And we compare channels by the shared pointer, and then we know it's the same channel. And this didn't work for me, because when I moved the code to Rust, I had copies in Rust and I had copies in C++. So I had two memory locations, and so the whole memory location strategy failed for me. And back then, I decided to introduce a channel ID instead, which is just an incrementing ID. And I changed
Yeah.
all of the code to identify channels by their channel ID instead. And that stuck to the code. And I think it makes things simpler now, because most components are not interested in the channel. They just need to know the channel ID. They just need to know, I need to send a message to this channel, to the channel with this ID, and they don't need the full channel. And that makes writing tests easier, because the channel ID is just a number, so I can make one up in the unit tests.
So, so rather than, I mean, passing a shared pointer around isn't entirely heavy, but this is, I guess, is just an opaque handle to the channel ID, so it needs to be looked up by ID. And what,
Yeah.
so what is that? Just like a U64 that increments forever?
Exactly that.
Yeah.
And that wraps around.
Yeah, I mean, yeah, it's one, you could do that either way. I mean, one thing that we're trying to work on right now is dealing with nodes that have that are multi-homed. So dealing with that in a clean way. And that's things like IPv4 and IPv6 address. So I think what we're trying to do is start to handle things by node ID. And in the handshake, each channel like lists its node ID, and then you have multiple like connections per node ID.
Okay.
But yeah. Okay, so you did this mainly because the
yeah
pointer stuff isn't really playing well.
Yeah, that's where this all started. And the channel ID is we can't go down this rabbit hole, and it goes deep. So, and I'm not even sure if I want to leave it like that. So this is something that I see as an experiment for the Rust code base itself. I want to see
Yeah.
if it is problematic, or if it makes things simpler. But yeah, I want to just stay here, because I made a lot of changes to the network stuff and to the channels. And so right now, when you want to send a message, you can just give the channel ID and a reference to the message. And again, the message is not heap allocated; this is all stack allocated. And
Demetrius just pointed out one interesting thing is that if we use channel ID rather than a memory address, that would offer support for running like network code out of process, which is a good point. That is one of the basically layers that would be interesting to have in the future, is having networking code in a separate process.
Oh, wow.
Just for the security benefit of not being the same process.
I've never even thought of that. Yeah, that's a good point. Oh, there's so many questions. Maybe should we we wait or read them now? Bob is here. Hi, Bob.
I don't know. Up to you. It looks. What is Roger saying about chat?
Roger says,
I don't know what that one is.
Where this one? How do I tell people who aren't seeing messages on chat that YouTube sets it to main messages only by default, and they have to set it to live chat? Yeah, okay. So now you know, guys.
Okay. Bob was pointing out the unit tests have some issues with timing. And yeah, that's kind of just, yeah, the unit tests tend to have like race conditions on them, probably because they aren't, we didn't write them well to start with, but also the code has changed a lot over time, and we add like new buffers in the middle or multi-thread things. And
yeah, but also so in your defense, those tests are really, really hard to write well when you have so many threads interacting and time is an issue. This is really tough to write well. And yeah, that's why I'm trying to write the tests.
There's some things you just don't do well.
Yeah, that's why I'm trying to write the tests deterministically. So I don't want to have those full nodes running with threads and infrastructure. And I want to just stub out all the infrastructure and just test very small components and make the tests non-flaky. We have a long way to go.
Yeah, I think that's a good path.
Yeah, so back to the message publisher. So components can call the try send, and it's called try send because the message could be dropped. So this returns immediately, and it either enqueues the message. So we have a queue in the channel, and it either enqueues the message or it just drops it immediately. So there's no waiting here. And the other option, and I don't think this is in the C++ code, is the async version of send. And this will block until the message is out. No, that's not correct. This will block until the message is in the queue. The queue is limited. So it will wait for a free place in the queue. And once a place is free, it will insert the message into the queue, and then it will return. And this is very helpful if you want to throttle. So let's say you want to send out messages like in the legacy bootstrap. I think I used this when you send out messages and you want to wait until the message is out and then you want to send the next message, just to push out messages as fast as you can and not drop messages.
Yeah.
So, yeah.
That makes sense. I think I mean, part of what is required for this is a runtime that supports async stuff, and C++, at least until recently, didn't make that very easy. So having it all on threads. So for things like Bootstrap, it's running in a thread, and you either block on the send or you wait, basically.
Yeah.
And now with so Piotr did a nice experiment, and we do, I think the TCP list was rewritten in it, but you can do async code with coroutines. And yeah, it's things like this where you can async wait on stuff, and the coroutine suspends and resumes when things happen. I fully supported that for like networking code. I think it's much cleaner, much better to understand.
Yeah, the callback style is really hard to wrap your head around. The old callback style, yeah.
So, I agree. I mean, and especially when they couple it with shared pointers, that's one criticism I have of kind of, it's really the like Boost documentation and how they recommend people do it. So the first thing they introduce you to is like this callback style, and recommend that you put shared pointers in the callbacks. And that's, so that the shared pointers keep the memory of the thing that they're accessing. But they also teach this pattern, which I disagree with greatly, that I guess the pattern is, I don't think the callback should be just determining the lifetime of the object. I think it should have like a reference, and the lifetime should be done externally. Like the network, you should have it in a reliable state where there's no outstanding sends and receives. The network code isn't doing anything, and then you deallocate it. Because I think one of the most annoying things that we had was finding dangling references or premature freeze on the like networking code that's holding shared pointers, and it was an absolute mess. So I don't think they should be showing that like pattern. I don't think it's good.
Yeah, I agree. Yeah. Yeah. And are you planning on switching to the coroutines, or is Piotr planning on working on that?
I think in general we are. I don't know how that's gonna like shape up and everything, or when we'll do it, but I'm like, part of the thing is we did this as an experiment to see how they work. Because I experimented with the coroutines like 2 years ago, but they were using boost coroutines, and it needed like special support. It wasn't cross-platform. It wasn't part of the language, and yeah, I think it didn't work on like Mac or something. So it's just can't use it. We're cross-platform, but now with the language support and boost support for it, I don't see anything in the way. So I think the first step is going to be deleting the legacy bootstrap code so we don't have to try to port that, and then move forward.
Yeah, sounds like a plan. Yeah. I think there the network code is one of the most difficult parts to understand currently. Oh, let's check what the chat says. Roger Cruz says, integration tests are hard. That's why our mocks for the unit tests are all synchronous single-threaded code. Okay, once you have the protocol as pure documentation true to both CPP and Rust, I expect a Cambrian explosion of nodes in different languages. Golang, anyone? Yeah, but so Colin and I, we talked about this before the stream. Like, so people underestimate how much work that is, and I underestimated it too. I thought I would be done in a year, and now it's 2.5 years, and I'm not done yet. Yeah. The amount of work to port the node is, yeah, don't underestimate it.
Yeah. I think somebody else was asking about, like a formal specification of the node. Yeah, so right now we basically have like a de facto reference version in C++. And I totally anticipate, like, as time goes on, we will get a specification for it. Part of the reason not to do that is what currently, or at least in the past, was we don't want to ossify the protocol when we weren't done developing it. There's a ton of new stuff that we put in, like stuff we learn, even in like the Rust codes, like we'll learn things, and we don't want to be like tied to an old specification for things. But as time goes on, we're going to be changing less. We'll know what works and what doesn't. And yeah, that's the point where like specs are really beneficial for that exact reason. It's like we can all just look at the reference and know and agree exactly on how things should be done.
Yeah, makes sense. Okay, so yeah, so back to the message publisher, and it also has this function flood PRs and some non-PRs, because that is a function that is used from some places where we want to publish a message to all PRs and just to some non-PRs. And this is in the C++ code, is in the network class. And the network class, as you know it, doesn't exist in Rust anymore, because I think it has way too many responsibilities. It does stuff like this sending of messages and flooding of messages, which is okay. But it also creates very specific messages. So there are functions in there to create keep alive messages. There are functions in there to create other types of messages, and it manages the channels and stuff. And I wanted to separate those responsibilities so that the message publisher would only publish messages, and the network class, as you know it, will only manage connections. So maybe it's better to have a look at it in here. And I'm not fully convinced that this is a good design, by the way. So please roast me, or maybe you have a better ideas here. But I found that the network and managing the channels is a complex thing, because there's many rules in there. For example, if this IP address is, if we are connected to that already, then refuse it. If we have a node ID connection already, refuse it. Or if the peer misbehaved in the past, refuse it, and stuff like that. And I wanted to write tests for them for that without requiring real network connections. And And so my idea was to have a hard separation between the actual channel with the TCP stream and the metadata. So all the data, when was the last packet sent, when was the last packet received, what's the protocol version, are we in bootstrap mode, are we in real-time mode, how is the queue full or not, and all of that. If I could just split this metadata from the actual channel, and then I wanted to implement all of those rules by just using the metadata, and that's the green boxes. So when I draw diagrams, I always color them now in green. Green is pure logic, and red is infrastructure. And with infrastructure, I mean everything that is outside of our program. So that's network, disk, clock, database, you name it.
Yep.
And then the blue boxes are application layer, and application layer connects infrastructure and logic. So that is the mediator, the glue between the both worlds. And I wanted to have all of those rules, like when to close a connection, when is it the timeout. I wanted to have all of those rules in the green boxes, in the logic boxes, so that I could test them without having a real connection. And so that's this design here. And I'm not sure if it's a good idea, and maybe I'm going to change it in the future. But this is how it looks right now. So I have a class called network info, and that's just a stupid name. And I need a better name. I don't have one yet. And I have a class network. And the difference is network info is a collection of channel info, and that's the metadata of a channel. And the corresponding network class references that, and it additionally holds the real channels. And with the real channels, I mean the channels that have the actual TCP stream. And these classes are very slim. There's nothing in there really, because all of the logic is in the green boxes, and that makes it possible to write tests for that behavior very simply.
So the channel info has channel ID, and I presume that the actual like channel in this blue box also has the channel ID, and that's kind of how it does the lookup.
That's and there I think it even has I think this is an arc. I think it has a direct reference right now. Not sure if that's a good idea, but that's how it works currently. So I can write all of the tests on the logic part directly, and let's see, maybe I can show you some tests. Oh, I hope that I have tests now. Should have checked before. Let's see, where is network info? Network info. And are there tests? Yeah, there are tests. So for example, purge if last activity is above timeout. So here I'm just creating the network info, and also the clock. The clock is, there's no clock involved. I'm just working with timestamps, which I can create in my test as I want. Then I'm adding a channel. So this is how we add a channel. I say, this is my local endpoint. This is my remote endpoint. This is the channel direction. This is the channel mode. And then I can set the last activity on the channel, and then I can call the purge method, and I can ensure that the channel was purged. And all of those tests here, don't purge new channel. Yeah, I have to write a lot more tests here, I guess. Yeah, what else is there?
Yeah, I think, the way that we did that was making an in-process channel, like subclass.
Yeah, I deleted all of them. So I don't have different channel types anymore. Because with this channel ID change, there was no use anymore for in-proc channels and for dummy channels. So a third one. I think the C++ has 3 channel modes. I think the TCP, the inproc, and the dummy one, I think. And so there are no different channel modes anymore in the Rust node.
Yeah, I'm trying to see how many there are on that. So like as a thought experiment on that diagram, if we were to like start adding QUIC support with instead of just TCP, and we want to support both, like how would that fit into this?
It wouldn't fit in directly, so there would be a change needed, and the change is here on that level because the channel uses the TCP stream directly, and we would have to
Hmm.
insert an abstraction in between. I've noticed that in the C++ code, sometimes components work with the channel, and sometimes components work with the socket. And I think that should be
Yeah.
changed so that we only work with channels there. And I've made that change in Rust already. So all of the code that sends and receives data is only using the channel. And if we want to have a different channel backend like QUIC, we would have to insert an abstraction here. And I didn't do that
Yeah.
because Yagni, you aren't going to need it because who knows when we add QUIC support.
Yeah. Yeah, exactly. The what was I going to say? Yes. So, oh yeah, on the stream or directly accessing the socket. And you're right. That's a whole other abstraction. I think the only place in our code that still uses that is the legacy bootstrap. And that's another reason we want to axe it. And we didn't originally have an abstraction for channel. We were using like TCP or something directly. So the only reason that we have the channel abstraction is when we added TCP support. We were originally using UDP. So we did have a reason for multiple things to be there. But then we got rid of UDP support partially so that we got rid of UDP support because it has no flow control. So
Okay.
we got rid of that. So there were two things for it, which is why the abstraction remains, even though there's only one consumer of that abstraction. So we designing it from the beginning, we probably wouldn't have put that abstraction in right now, and we would have added it just as you are, like once it's actually needed.
Yeah, I think it
Which
will
is
not
good.
involve all of the components. It will just be a change in the channel and and the backend implementation. So the channel, backend, which would be TCP or QUIC.
I mean, it might be. I mean, one issue that you might have is, this is another example of multi-homing. So it's multi-protocol homing, where a node is connected. Its same node ID has both a TCP and a QUIC stream. I have a feeling that the channel IDs are going to be difficult to manage, and you might have to use the node IDs, but I don't really know because like if your code is using channel ID,
Oh,
um,
it's just using channel ID for sending messages. But we could use
does
node
it use
IDs.
it like in does it use it in response to like a request like
Yeah.
yeah, I mean, it makes sense why you'd want to reply in the same channel that you got it in, but like at a more abstract level, you want to send it to the same node ID, um, to the same node, not necessarily the same channel. You probably want to do the same channel, but I could foresee an instance where um,
I can see. Yeah,
one of them
I
is
can see a
full
point.
or something.
Yeah. Makes sense. You're right. I want to reply to node ID. And also, there's this rule where we can only connect to a node ID once.
Yeah, that's problematic. That's just kind of layover, and we have plans to not have that restriction. So what we want to do for multiple reasons, one of them is there's entirely valid reasons to want to connect to the same node multiple times, but then there's also reasons why we don't want to do that. But then there's also the fact that people can present themselves as a node, as like a man in the middle. So we want to support that multiple.
Okay.
We have to do a whole bunch of things for like bad behavior, like scoring nodes based on how responsive they are, and yeah, basically prevent people from sitting in the middle.
Oh, the banning nodes. I made a change just because I didn't know better. Because when during testing, I noticed that the node kept reconnecting to itself, and I added a couple of lines of code that if a node connects to itself, that then it would ban itself, or it would ban the IP address. And this is not in the C++ node, and I just added this because I found this so annoying in the logs to have all of those connections from itself.
Yeah, I thought we have some sort of prevention to connect to ourselves. Because yeah, that's one thing that doesn't really make sense. I don't know. It might kind of make sense. I mean, the one case where you'd want to like maybe logically connect to yourself is for vote broadcasting. So part of the node generates votes, and part of the node like tallies them up. And I
Yeah.
think what we do right now is kind of have an internal passing of that vote to between those components. But the other possibly more correct way to do this would be to have a connection to ourself, and we simply only pass our vote to the network, which also might include ourself on that component.
I think
Um,
we are using an inproc channel in the node so that the nodes, or the C++ node does this, the Rust node doesn't anymore. The C++
okay.
node uses an inproc channel so that the votes are handled. Its own votes are
Yeah.
handled. And I changed that because that was the last part that used inproc channels. And I thought, why would I need an inproc channel just for this part? And I refactored it. And I'm not sure how I changed it. I think I just call the handler function directly or something like that. Or I
Yeah.
enqueue it. I'm not. I don't even. I know. I know. This was. I now remember. It was the due to the channel ID. Every message is connected to channel ID. I have a special channel ID which I call loopback, and that's the number 0. So by
Okay.
enqueuing a message with the channel ID 0, that's the same as an inproc channel.
Okay. Yeah. Yeah.
Yeah. So
Different ways to handle it. I don't.
I'm also like curious how if this will stay like that, if it pays out, if it is okay. If it's causing too much trouble, I can change it again.
Yep. Absolutely. Yeah, this is what I mean. You're hitting one part of things that are hard to test. Anything that goes outside your program boundary, like TCP, file access, um, all that kind of stuff is really hard to test. I think what comes to mind is some people like do things called fault injection. I think that's one of them. But basically, I wish operating systems had a better way to test like all of these edge cases on, the file
Yeah.
became unavailable. How do you
Oh,
test that in your program? Well, it's basically impossible.
let me tell you about my most favorite testing technique. And if you, I think you've heard it already because I'm preaching this. I'm preaching this over and over again. The testing without mocks pattern language from James Shore, which stubs out all of the infrastructure, and you can simulate all kinds of error cases there.
Oh, nice.
And I have not converted many places to that pattern, but I've started and I had good results with that. For example,
Okay.
the node ID key file was a place where I tried that out. And let me show you the tests. So what the node ID key file is a lot more code in Rust than it is in C++. Because I wanted to test every edge condition. And what it has here, this is the magical part, the nullable file system. It's a file system wrapper that I wrote, and it's highly reusable. It does, it wraps the standard Rust system, file system functions, and it enables me to stop them. And in that way, I can return every error condition that I want. And also, I can write unit tests that don't use the file system, the real file system. So if I scroll down here to the tests, for example, fail if file is inaccessible. So writing tests like that with a real file system is difficult because you have to create a file, you have to make it inaccessible.
Sure.
So what I do is say fs with inaccessible key file, and when we open up that function, fs with inaccessible key file, it creates a nullable file system. It says path exists. So because we call the path exists function, so we say the path exists, and we say when read to string is called, it fails, and here we can say permission denied. And that creates gives me the nullable file system that I use in the test, and the test calls fs read to string, and it gets the error, and I can test it, and no file is ever created.
Yeah, that's interesting. I mean, that's if you have to design it on the user end, and the operating system doesn't support this, which nobody does. Yeah, this is a good way to do it for that exact reason. Yeah, you kind of inject yourself in between the lower layer. So when you're using this code, you're just using like actual file system and not nullable file system. Is that polymorphic or?
It is polymorphic under the hood. So there's only one struct nullable file system, and it has a strategy, and the strategy is either the strategy is real and for the real file system, and it is nulled with a stop. And when you create the file system, you can either say new and it gives you a real file system, or you can say new null and it gives you a stop. But it's always the same file system. And so I don't have to have traits. So I just have the nullable file system. And it has built-in observability. So I can also, when I go back, I can also test for certain events. Do we have that here? Here. Create file with private key. So we say initialize nodity without existing file, and I get back a list of events, that file system events, and I assert that the first event was a create dir all, so that directories are created, and the second event is a write event, which wrote the expected key to the file. And this observability is not just part of the stop. This observability belongs to the nullable file system, so it works with the real file system just the same way.
So are these events like memory allocations?
They are, because they use a queue. But the good thing is, if there are no listeners to the events, then no allocations happen. So it doesn't.
Okay, so
it doesn't cost.
So it isn't like. So it isn't like the actual issuing of the request. It doesn't go through the queue. It's just like a record.
Yeah, it's a record, and it only puts the record into the queue if there are listeners. So it does not hurt performance too much. And
yeah, I mean, it's like tracing pretty much.
Yeah, exactly. So the good thing with this technique is that you don't have to spend a lot of time writing this nullable infrastructure wrappers. You just have to do it at the very base layer. So that's file system, clock, network. And I've made, so this diagram here is the current structure of the Rust code, where I try to gradually introduce layers. And at the very bottom, I have my nullables, and these are already written. So I have nullables for the file system, for the clock, for the random number generator, for TCP connections, for LMDB, for an HTTP client. And output tracker is this, what you just saw, the event stuff. So all of them use that. And so I had to write them once, but they are highly reusable. And I think we don't need more in the foreseeable future. So all of the tests I write now, I can just reuse them.
Okay, interesting. Very, very interesting. So, I see there isn't a RocksDB nullable.
No, yeah, it breaks my heart that we are switching to RocksDB now because I deleted all of the code.
No.
So.
Yeah. Well, I mean, maybe you can play with the flags that we were playing with.
Yeah, I wonder. You said it was slower when you disabled the syncing. That sounds so weird.
Yeah, I don't know what's going on there. I'd like to retry the test locally. I mean, we were trying it on a live node. It's very confusing. I don't see why it would get slower. It got extremely slow, actually. So that's really weird. I don't know.
That's
At a
super
certain
weird.
point, though, it's like I'm twiddling a bunch of flags on this database. I mean, yeah, who knows?
Yeah, maybe.
Um,
So let's just check the comments. Andofno says, I'm fine with the amount of work you have to do, Gustav. At least we have a decent stream to watch on Tuesday evenings. Okay. Thanks for doing that. Okay. Alstorap says, hi guys, next project, Gustav will port Nano to Lisp. Oh, no. Although I like Lisp, I've actually written a couple of hobby projects with Clojure.
yeah, Lisp is interesting.
Yeah.
I mean, I wouldn't program anything in it, but I think it really gets your brain thinking in a functional way.
Yeah. And the syntax is so simple and so powerful at the same time. That's a cool language. Delete-oriented
Yep.
programming, my favorite part of refactoring stuff, says Roger. Factory functions for your mock with stubs, nice. And Dimitrios says, there's no reason for the RsNano to use the same database as C++ node, is there? So I want to keep it compatible as much as I can because I want to give people an option to try out both. And right now, even the database should be compatible. So it should be okay, although I'm not recommending it. It should be okay to switch the nodes and just use the same database files because I haven't made any changes to the database structure.
Yeah, that would be ideal. Actually, I mean, that's one of the things we were just talking about on the dev space today was making a better abstraction for our storage things. So maybe, maybe if you wait for us to get that, we might give some ideas on how to do both of these things in a cleaner way. So I still have to figure out how we're going to do it. I got an idea on how to, but yeah. Be nice. I still think multiple database backends is something that we should keep supporting because, yeah, who knows? Something new may come up. I remember some people wanted to have a SQL backend because they wanted to query things. I don't think we'd ever do a production SQL backend because I think that would perform terribly. But
Yeah.
yeah, it might be interesting for querying things or having like a logging node, something.
Oh yeah. Oh, I'm crying now. I have to throw out all my LMDB stuff and bring back RocksDB. But yeah, I'm gonna do it if you guys do it.
We'll try to make it easy.
So we deviated quite a bit. So from the message publishing.
Yeah, so I think we're on the non-allocation of.
Yeah. So I want to show you something where I still allocate and my idea of how I can get rid of those allocations, and I'm interested in your opinion there. So when we send a message to the channel, when we send a message to the channel, we put it into the write queue, and that is similar to what the C++ code is. And the write queue is actually two queues. We have the generic queue and the bootstrap queue, so that is also just the same. And here is where I still heap allocate for every message, because the queue contains an argvacu8, and that is the shared pointer vector, the same thing as the C++ code still. And this is, as far as I know, the only place where I heap allocate still to put it into the queue. And I wanted to change that so that the queue is pre-allocated with packets of, let's say, 256 bytes. And I would just want to split the message up and put it into the pre-allocated queue, just reuse the memory, and have a flag in there when the message is done, if it is split up into multiple packets. And on the queue handling side, there I can just copy that memory into the stream. And that way I would not need to have heap allocations. So let's open up
So this buffer, is this like a concatenation of the serialized things that are to be written to the network stream?
yeah, and practically yes. So, but I also need to make sure that I only write a complete message. So I can't write, I don't want to write half a message and then go into waiting loop again. So this is the place, this is the processing the write queue. So this is a task running in an async task running in the background. It loops, and it pops the next message, and then it writes it to the stream here. And I want to change that so that it pops those fixed size chunks, and it pops them until the whole message is was popped from the queue, and it writes them into the stream. And I could do that without any allocations then. So that is my plan.
Yeah. Yeah, so the fixed chunks would be like a slab allocator.
Yeah.
And you would check out, your 256 byte chunk, whether or not you're going to use it all, doesn't really matter. And then once you're done using it, you stick it back into the slab allocator.
Yeah.
Yeah, I think that would work. And that's generally, I think, how the only difference that I would be thinking in the future is it kind of just more at a high level. I'm wondering if we should not manually specify our message types. Like we are specifying our own message formats. And like, for instance, one that's extremely problematic for us is telemetry, because it's a rigid format. We have impossible stuff that, like, it's impossible to add things to it. So maybe just using something like flat buffers would be advantageous, because the way flat buffers works is it keeps things in the wire format directly, and when you do the accessors or the mutators, it modifies what is the underlying object, and you can just write the whole thing directly. It would still use a slab allocator though. So yeah, I think there's good benefit to doing that.
Yeah. Sounds like a good idea.
What are you going to poke holes in telemetry? This one is an interesting class.
Yeah, because of the unknown data at the end, right? So
yeah,
that
one, that's just like a hack.
Yeah. Ricky had some issues with it. Yeah.
This is one thing I think if we wanted to start playing around with flat buffers, we should just make a new version of this telemetry message, because it's a nice, easy one to go off. It's only a nice to have. And yeah, that would be interesting.
But that would also mean that we would have an entirely new protocol, right? So we would have to redefine.
Not necessarily. We could like we already have existing message types. Like we could make a new message type that just says it's a flat buffer encoded message.
Ah, okay. And keep the old messages.
Yeah, we could use them both simultaneously. It'd be nice to strip off eventually our format. So maybe we can do some thinking around that. Maybe when we move to QUIC, we could make QUIC only support the flat buffer files or flat buffer messages, something like that. Because we don't want to keep this like legacy message types going forever. If we replaced all our messages with flat buffer messages, it'd be nice to not have our custom format.
Mm-hmm.
Yeah.
Yeah. Yeah. Sounds
Okay,
good.
cool.
Sounds good. Okay, so what to do now? So yeah,
Where's our list of
so yeah, as you see, it's not entirely allocation free, but it's already looking good. There is another class. Let's just very quickly have a look at the message, because we only had a look at the serialization. I also created a message deserializer, or is there one in C++? Not sure.
Yeah, there is.
There's, okay. Yeah, okay, then this is nothing new. Let me just quickly have a look at it. Does it parse read? Yeah, maybe the only difference is that this is async.
Yep. Yeah, exactly, which is really nice because obviously this stuff is very easy to understand. It looks like normal code, whereas I forgot what our message deserializer looks like.
Yeah, it uses a lot of callbacks, and it took me a lot of time to refactor it into async. But now it just it's pretty clear. It reads the header first, and when the header was received, it validates the header, calculates the payload size, and then it parses the message. So there's no callbacks in here anymore.
Oh yeah, callback types. Yes, yeah. See, that's the problem with this callback code, because it also with C++ how you have to declare all the functions. It makes you want to write longer functions just so you don't have to go through the pain of writing new function signatures.
Yeah.
Roger's got a question.
Roger said, unrelated, do you think it's possible for a wallet to use the same peer discovery as nodes and talk to them that way to load account data and publish blocks? Backend-less wallet.
Yeah, there is. So we would call that like a light node. We don't have one like C++. The C++ isn't a light node. I think somebody wrote it in JavaScript, and maybe it was Trashman. So yeah, somebody wrote one, and yeah, we do want to support it. There's some peculiarities with it, because in order to know the ledger state with Nano versus like a monolithic blockchain, you have to track more things, which is harder, but it's doable. And we just, haven't done it yet.
Yeah, Demetrius also says, if you have a trusted list of PRs, then it is possible. Getting the current PR list is a difficult problem to solve.
Yeah. That goes into kind of decentralization. I mean, also finding the highest block height is like in the pure math sense. A light node couldn't do that because it takes a ton of bandwidth to do it, but you can estimate it pretty well, and that's why those are nice and efficient. One alternative you can do to get a PR list is to ask somebody that wants to receive like Nano from you. So if you go to a merchant that, like, let's say in some future state where Amazon accepts Nano someday, you can ask them for the PR list, because they have every incentive to tell you the truth, because you're sending them money. They're not going to counterfeit to you because they're the recipient of the money. So there's some ways to do it. we just haven't committed it to it because it's another thing to maintain. And yeah, it just takes more time.
Let's go back here. So we talked
What about the
about
stats decoupling?
we talked. Oh, I didn't want to make that. So we talked about this one. Let's just delete stuff we talked about. We talked about this heap allocations. We talked about that. Nullable infrastructure, AFM architecture, nullable. Yeah, so we talked about that.
Mm-hmm.
Cyclic dependencies removed. Later architecture. We talked about that. We talked about a lot of things, huh?
Yeah, we did. We're really knocking this list off.
Network info, socket class removed, separation logic infrastructure, central management of all connections. We talked about that. When I just read central management of all connections, because in the C++ code, I think we have the management of the channels in the TCP channels class, and then additionally in the TCP listener, if I'm right. I'm not sure if I'm right, so this is dark memory.
Yeah, we do. The TCP listener would be like the incoming ones.
Yeah. And I found
Yeah,
code duplication between managing the channels in both. So the rules, for example, the rules with the blocked IP addresses was duplicated, and
I wonder why we do that.
Probably historic, probably because it grew into that.
True. That just seems like something that could be removed, though. Yeah, that's interesting. Connections, list connections. Why do we have a list? Yeah, that's interesting. That's something we should look at. I mean, I bet if I were to guess, I would guess Piotr's looked at this and has a plan on it. But yeah, maybe I can ask him.
Yeah, let's remove that. Okay, so your interest. Yeah, okay, so this is a controversial topic, stats decoupling, because we talked about it a bit on Slack, and I know, for example, that Piotr doesn't like my preferred way at all. So, and with reasons. I mean, I can understand why he doesn't like it. But my issue with the stats is that it is having too much knowledge, because let's open up the stats. Stats. Oh, sorry, wrong thing. Stats. So the stats enums. So every time we add something, we change something, we work with the code, we have to adjust this enum, or a lot of times. So this enum gets changed a lot, and so that makes it a central component that changes a lot, and all our other components depend on this, and that's why I don't like it. I don't like that we have in the middle or in the center something that changes all of the time, and around we have all of the dependencies here that have to recompile, and that violates the dependency rule. So our dependencies should point into the direction of stability, and we should not depend on something that is very unstable, like the stat type. And so
yeah, that's a good way of phrasing it, pointing in the direction of stability.
Yeah, so that's why I'm not happy with using the stats in the way they are. And we talked about it on Slack, and I think you said maybe we could do it in the way the error, what did you say? The error codes, it is done with the boost error codes or something like that?
So there's like, yeah, the C++ error codes.
Yeah.
where you can add more components. I mean, probably more straightforward ones are how we organize the config objects, or how we organize like the um, yeah, I guess like right here, what we're doing is this is kind of just a concatenation and an enumeration of like component and then counter, or things like
Hmm.
node subsection, class name, specific variable type. The other way to do this is to just start is to like have a string that does it, that you append to, with like a dot separation between the logic.
Yeah, that's also something that I thought about, and I think it would be a generic and well working solution. And Piotr said he doesn't like it because we then have to calculate the hash every time we increase a counter for the dictionary lookup, and it would hurt performance. And
Yeah, which is entirely valid.
yeah,
Um, I mean, so the other issue that we have with the stats here, and this is a more subtle performance thing, is one is we use like a mutex for one
oh
big
yeah,
mutex for increasing the stat counter,
yeah,
which is becoming a problem.
yeah,
So that's one thing, and then another thing that we're going to run into soon after that is going to be um, what would we call this? Like it's going to be cache thrashing. Um, so we're going to be updating what are going to be entirely separate numbers from multiple threads, but they're going to be it's going to be false sharing. So we're going to start thrashing the CPU write cache, because all of these are like in one memory region, but they're like being accessed by different components, but the CPU doesn't know that. So it's going to like start locking the cache lines. This normally doesn't make a problem for virtually everything except for things like this, where it's like high performance, highly incremented numbers that are continuously updated by tons of threads. And yeah, we're going to start killing performance. So there is like a reason to probably separate these objects out by the include by like the thread that it writes to roughly, or the component
yeah,
that it is associated with.
yeah.
Um,
Also, so let me maybe sketch out what I have tried so far, and I personally I like it, but I can understand if people don't like it because it is more work and it is a little bit more complex. And let's start a new diagram. Um, so let's pick any component. Let's pick the ledger. Doesn't matter. Ledger. And so we have ledger and we have stats. And currently it's like that. So that the ledger calls into the stats whenever something happens. And what I have done is introduce the observer pattern, so that I've created a trait ledger observer, and then I had created a stats ledger stats, which would implement the observer, and the ledger would just call the observer, and the ledger stats would call the stats, like that. And then we would have this separation here, where the stats would then become the top level component. So the stats would be the component that would depend on all the other components.
um, yeah, I don't know. We might have some issues, because if that's calling a function object every time, I mean it's not going to help our performance problem.
No.
I mean the way that I mean, let's go back to what you were saying before. The dependencies should go in the direction of most stability. Um, I would envision something where we would have something like node stats, and all the node stats would have is like um, an array, or like a vector of subcomponent stats. So it'd have network stats. It would have, vote processor stats. It wouldn't have any of those things. So those vote processor stats would be separate objects themselves. It'd be a parallel like tree of objects that are just stat related that would one-to-one map with their associated container. And so the ledger stats object would only be associated with ledger. It doesn't know anything about node stats, but node stats knows about ledger stats.
Okay, let me sketch that. So we have ledger stats. And let's give this a different color. Oh, no, not the text. Ah. So we have ledger stats. Let's make all of this thing green now. So, and then we would have a global stats, which would like that.
We would have node stats because the node is composed of the ledger amongst other things. Yeah.
Yeah. Also.
So then that bottom right ledger stats, we wouldn't have the ledger observer. We wouldn't.
Interesting. Yeah.
That I think also solves our issue of like the hashing of strings. So we wouldn't actually, even though it's kind of like a tree, we wouldn't be doing it based on strings. We would just be doing it based on, just objects.
One thing I thought about is if we would not have multiple enums, because we have stat type and we have detail type and we have direction. So we have 3 enums that work in combination. I also thought about why not just have one enum with all possible values, and then we could just have a vector pre-allocated for all values with atomic hue sizes in them, and then we could.
Yeah, I think so. I mean, like the direction, I don't really like the direction thing because, actually 3/4 of the time that doesn't apply to whatever we're doing, but it's like in our base abstraction. So I think the only reason we didn't do that is because for some of these things, if we thought we had a problem with the large enumeration now, if we duplicate like half of them and do in and out for each of them, then we have an even bigger problem. But if we start breaking this down into like, networking stats and then like channel stats, and the networking stats has like, a parallel hierarchy of channel stats, something like that. Then you could just do in and out, bytes in, bytes out. And then for the stuff that doesn't apply, doesn't have like a direction, we just simply don't have a differentiation.
And that sounds good. I'm curious what the others have to say about that, especially what Piotr has to say about it. Yeah.
Yeah, I mean, if I were to guess, like I'm sure he doesn't have a problem with organizing it, but yeah, calculating a string hash every single time would absolutely kill the stats.
Yeah.
So I think this nicely eliminates that.
Yeah, if we can make your suggestion work, I would like it even more because it has less moving parts. We would not need to have an observer abstraction in between. So I like your idea better because it's simpler.
It would be nice to have some sort of a way. So the only other thing that I can think of is when we actually do want to produce a string for this, say for like instance, the RPC wants to have a string. So we do want to produce that hierarchy. We'll need a strategy to print like node.ledger. Stat name.
Yeah.
In a convenient way. I'm sure we can come up with a pattern about that. Yeah, the Grafana dashboard, exactly.
Bob asks in panic. Bob asks in panic, what about the Grafana dashboard?
He's like, don't break it.
Don't change it, you madman. Okay.
Yeah. No, but there, I mean, that's an entirely valid reason.
Mm-hmm. Where's the chat? Where's the chat here? Demetrius, the mutex taking during stat access can be eliminated by having the concept of per thread stats and then having a period sync from thread stats to global stats.
Yeah, that's not a bad idea. Yeah. I mean, yeah, you could write them on separate thread. It's kind of like a work stealing algorithm. You write them purely on the thread, Um, yeah, it doesn't totally eliminate it, but you can eliminate the contention. If it's multi-threaded, you still need synchronization between them, but what you can eliminate is the issue where we have contention where one's holding a lock and then one's waiting for it. You can eliminate the wait.
Yeah. So, but I think we all agree that the stats need a bit of love, like a little bit of rework, yeah, in one way
Yeah,
or another. And it has to be super fast because the stats are are a critical component.
yeah. This is actually a case where you can tell bad design by how long the compile takes when you change something.
Mm,
So if you ever add a stat counter to this, it
mm,
recompiles like 150 files,
yeah,
which basically just says it's too tightly coupled.
yeah, exactly my concerns about it. Yeah. And also, like this wasn't the other point that I noted for the stats. It is my opinion that stats are overused in the code. Um, it looks to me that we use stats for two reasons. Like one reason is to give the node operator insights into what's happening. And that's a perfectly valid reason for having the stats. And the other reason I see is that we use stats because we have a lack of tests. So we use stats instead of having detailed unit tests that make sure that certain, let's say, certain functions are called in the right way and certain, yeah,
Yeah.
invariants are yeah, kept up. And
Yep.
because we don't have those tests, we use stats for them. And that's why I have the feeling, I don't know what's your feeling. I feel we use too many stats. For example, we have many loop stats where we just make sure that functions are repeatedly called. And that's, for example, stats where I feel I think this would be better handled by tests that make sure that these functions are not stuck are always called in order.
Yeah. So I think all of the above. I think there's definitely cases where we're um, working around bad design or just non-decoupled design by sticking a stats counter, and the only place we use the stats counter is basically like in a test. Um, on the loop counters, I think, I mean, I'm sure Bob would chime in on it, but I think those are actually useful to see, to make it's just one thing to like unit test it and say, yep, the loop keeps operating, but it's a different thing to when you're debugging something on a node and being like, why isn't this working? And then you all of a sudden see like a loop counter is exploding or a loop counter stopped. And then exactly, you can tell as a diagnostic tool that it stopped. Um, so I think those are probably still relevant, but I do think there's probably a whole swath of counters that are just kind of cruft, and we thought they were useful at a time, but they're just never looked at or something. I don't know. It makes our Grafana dashboard really big, which is
Yeah,
kind of
yeah,
kind
it
of
is
annoying.
really big. Yeah, yeah, yeah. Maybe okay. I see your point with the loops. Yeah, maybe we should have a discussion about which counters we could remove to make the dashboard more user friendly.
Yeah, it could be. I mean, I think the biggest improvement, like if you wanted to try prototyping something, would be that like inversion of the stats, make the stats objects. They're almost kind of like if you look at the collection info objects that we have that collect stats counters in one way. I think something similar like that, because that's also another parallel tree of objects.
Mm.
These would be slightly different because those we create on the fly, and these would be ones that we maintain as the program's running. But it's similar.
Demetrius said something. Stats give us the ability to get data out of the node that we have no access to. For example, an exchange. I think we should err on the side of having too many rather than too few.
Yeah, it's probably good. I mean, especially since I think our performance, like the only reason having too many of them there would probably be for performance reasons, and I think we have some very low hanging fruit on performance that coincidentally aligns with this type of refactor, and I think
Yeah.
we could eliminate a lot of the issue for a long time.
Yeah, fair. Okay. So, wow, I wouldn't have thought that we would get through all of these points.
Yeah, I
Yeah.
thought we were going to have extra stuff. Is the no DB val just because you only have one database backend, or how does that work?
No, I just
That sounds very coincidentally
I
near
just put
what
it
I
on the
want to
list
look at.
because you talked about it or someone talked about it recently. Then that's just that I noted it because I have no DB val in there. Um, the
How
way
are you serializing it to like LMDB?
Oh, I'm not happy with it, but I'll show
Okay.
you. It is
Okay.
um, where to look, to see like some store, which store? Oh, your store. How am I? Let's see. Where's the put? Here's the put.
Okay. So that's
Oh yeah, I
endpoint
do.
bytes.
I have just introduced a trait, and the trait is serialize, which just writes the data into a stream. And I have also a corresponding deserialized trait that reads, where's the deserialize? Serialize. There is none. What? Oh, am I in the wrong file? Again.
The lowercase.
I think I switched the files accidentally. Deser. There's no deserialize. Why is there no deserialize? Oh, there try from. Okay, so I have an implementation of serialize where it writes stuff into a stream, and a try from which gets a byte slice, and it reconstructs the entry. And I just implement these two traits for each value that gets written.
Okay, so is the try from trait, is that one of the standard
Yeah.
traits that does the like try into or whatever?
Yeah.
Okay. Serialize byte writer. What's that byte writer? String byte
Byte
writer or buffer
writer.
writer? Sorry.
Buffer writer. This one. Yeah, that's something that I introduced very early in the project. It is a trait. Oh, I wanted to rename those. They all have the save in there because there were unsafe functions before. I have forgotten to rename it to. I wanted to delete the save part. Yeah, so this is just a trait where I can write bytes into a buffer.
Okay, so the the byte arrays is or byte vectors is the way you use it. So when the database does a lookup,
Yeah.
so from what is being passed into the try from? It's a reference to a byte. What is?
Let's go back. So this is the put function of peer store. Let's do the lookup. Where is the lookup? Exists, for example.
Get.
You mean exists, or is there get it or? Okay, the peer store doesn't have a get. Let's go to prune store. No. Account store. Account store has a put, a get. Here's the get. It does the lookup with transaction get. So this is this is a small wrapper about around the LMDB trait that I'm using, and it returns a result. It returns a result with a byte slice or an error.
Okay, a byte slice. Yeah.
So
Okay.
here's the byte slice in the OK case, and I construct a buffer reader around it. So the buffer reader is something that I wrote in the beginning, and then I deserialize the account info from that byte slice and return it.
Yeah. Okay, that makes sense. So yeah, your basic interface to it is the byte slice.
The byte slice, yes.
Okay.
And
yeah, I think that's what
yeah.
we were looking at doing, because the DB val right now is just, it's a byte slice. It's one that we manually constructed because none of the or the standard library didn't have one. Now it does. It has string view, but then Piotr also pointed out that C++20 has one that's for bytes, not just strings. So we'll probably be. I'm going to take a look at doing it that way. Just if we're writing our own abstraction, we might as well use the right tool. So we'll probably be coming in line with Rust in that way.
Yeah, but that's a good sign. Like if we both come to the same decision independently, I think the decision is a good decision then.
Yeah, absolutely. Yeah. I agree.
Yeah, I think that's it. I mean, the block validation in functional style. I mean, you implemented it too. So I think there's nothing new for you because you also have a branch that does that.
Yeah, exactly. And yeah, I just got to get that. It's a couple of things to work on. But yours, I guess, is being tested and used. So that's
well, only by me.
Good. Yeah, true. True. Do you have a Rust node running on like beta? I guess you have one running on live now. That you're talking about. So
yeah, so currently I don't have a beta node because I only have one test server in the data center, and the hard drive is too small to support both at the same time. And so I deleted the beta node, and now I'm focusing on bootstrapping and running a live node.
Yeah. Cool. Well, hopefully that will be. We'll see what Rui comes up with it. Maybe he can debug it. So yeah, that'll be really exciting.
Yeah.
Very exciting.
Really exciting because I think it's maybe just a couple of days or weeks, and then I can release an alpha version. And super excited what people are having experiences then with it and what they can tell me.
Yeah, exactly.
I hope it runs well.
Well, yeah. Well, one thing about handing it out to users is they find new and interesting things you never thought of before that you gotta work on. But also, it sounds like you have a lot of people that are interested in it, and hopefully you get some, more contributors. You have a couple people already, it sounds like, which is very exciting. So yeah, congrats on that again.
Oh, thanks.
And yeah, I think this is really good. I think it's a good cross idea pollination. I remember the first time I heard you were writing the node, you came to London for one of the meetups.
Oh yeah. That was the first time we even saw each other. Yeah,
exactly.
And I stumbled into this really. I had never planned to invest so much time into this, but it was such a joy. And you and the Nano Foundation, you are also such welcoming and supportive people. And yeah, I'm still enjoying it very much.
Yeah, absolutely. No, it's great to have you there. I love your ideas, and yeah, we're looking forward to everything that gets going, or as we get more tests and more people run it in production. That'll be a very fun day. So
oh yeah, I can hardly wait for that to happen, to see the first Rust node on the live network. But that was great. Thanks to both of you for taking this much time and discuss all of this on stream. Yeah, and Colin, thank you so much for taking so much time and joining this stream here. Really appreciate it very much.
I enjoyed it. We'll have to do it again one of these days. And thanks everyone for watching.
Thanks.
Great to have you here.
And see you next time.
Yep. Bye everyone.
Bye everyone.
Bye.